Hello and welcome to the second part in this series on defining your own data sets using the Sage Intelligence Connector module. In the first lesson, I introduced you to the connector. I gave you a brief tour around and explained the different data objects that are used to define your data sets. I ended it by showing you how you can create your own connection to your Sage Accounting or Business Solution database. I've mentioned before that Sage Intelligence often provides you with more than one way to do something, and the connector is no different. In this lesson, I'm going to show you the easiest way that you can define your own data sets, which is by using the Graphical Join Tool. It is intended for those of you who are starting out working with a connector and that aren't too familiar with SQL. I'm going to do this by creating the accounts payable container for the receivables and payables dashboard that I designed for my business. I've shown the final report on screen again to remind you of what we're working towards. At the same time, you'll learn about some of the other standard connector functionality. Let's get started. I'm going to be working with the Sally's Data Sets connection I created in the last lesson to keep things organized. Remember, the next object in the connector hierarchy is the container. In the last lesson, I showed you the standard containers provided with Sage Intelligence. And something to keep in mind when thinking about a data set for a report is whether it may have already been defined, at least to some extent, in one of the out-of-the-box containers. Then, rather than creating a new data set from scratch, it may be easier to modify one of the existing ones. You wouldn't want to change the original, as this may impact the reports that make use of it. So, like with the reports in Report Manager, you can make a copy of one. I'm going to copy and paste one of the existing containers into my Sally's Datasets connection to show you how this is done. Simply expand the connection with the container you want to use and select the container. Then, on the Home tab on the menu ribbon, click Copy. Next, select the connection you want to copy the container to and click Paste. You'll see the container added, and you can now start tweaking it to suit your needs. I'm not going to go into any more detail on this now, as you'll pick up the necessary skills on how to do this as I work through the different examples in this series. So let's move on to adding a container from scratch. To do this, select the connection you want to use, and then on the Home tab again, click Add Data Container. You'll see there are different types of containers to choose from, one of them being the graphical join type. I'll get to it in a bit. The simplest of these, though, is a table and allows you to pull information from a single table in your database. As an introduction, I'm going to select this one. You'll then see a list of all the tables in your database and can choose the individual ones you want as data sets. The names of these tables will depend on your Sage product and may not always be self-explanatory. If you're struggling to identify which ones have the right information for a data set, then get in touch with Sage support. They may also be able to provide you with a data dictionary which will contain detailed information on this. Adding individual tables as data sets may not be very useful, but say, for example, along with the two I'm going to create for my receivables and payables, I want to get a summary of what I've received from my customers and paid to my vendors for Sally's necessities to date. This information is contained in my Accounts Payable Vendor Purchases History table and Accounts Receivable Customer Sales History table. After selecting them and clicking OK, they are added individually under the connection. Another handy function provided in the connector is the ability to sample the data that will be returned for a container. To do this, select the one you want to sample, and then on the Home tab, click Sample Data. A view of the data is then shown in table form in the Properties window. Typically, if a data set contains more than 50 rows, only the first 50 are shown. Adding individual tables and sampling their data can be another way to identify the ones that you need for a larger data set. And sampling the data in a larger data set is a good way to ensure that it's returning the right information. With that being said, I'm now going to start creating the container for my accounts payable. I'm going to go ahead and add another container from scratch. and this time select Graphical Join as the container type. I'm then asked to give it a name, and I'm going to call it Accounts Payable. After clicking OK, it is added to the connection. I want to view the properties for it, so I'm going to select it. You can see the name that I just gave it. I can add a description if I like, and can change the type from here if ever I need to. With the Graphical Join type container, you then have the Graphical Join Tool option, which you can use to start defining the data. Clicking it opens up a new pane in the Properties window, and the Table Selection dialog opens as well. You then need to select the tables you want to include in the data set, and this time, rather than being added as individual containers, they need to be joined together to form one complete unit. My accounts payable is derived from each invoice that I receive from a vendor for the furniture I've purchased from them. And in my Sage Business Solution, an invoice is stored separately as the invoice header and the individual purchase lines that make it up. This suggests that the tables I need for my container are my Accounts Payable Invoice History Detail, Invoice History Header, and Vendor ones. I could include a few more, for example, my division and vendor contact tables if I wanted to get some extra details on my purchasing divisions or my vendor contacts, but for the sake of simplicity, I'm not going to worry about this right now. After clicking OK, the tables are added to the pane in the form of an entity relationship diagram. This represents each table as a block with its title and a list of all its fields. You can move each block around or resize them to make things clearer if you need to. The next step is to join the tables together, and this is where the Graphical Join tool makes this easy. So that you understand what we're about to do, I'm going to share a bit of database theory, but nothing too heavy. When a relational database is designed, each table in it is intended to represent an entity in the real world, and these entities have relationships with one another. For example, I have a table recording the vendors I make purchases from. Each of these purchases is recorded as an invoice with the header details stored in the Invoice History Header table, and each purchase line stored in the Invoice History Detail table. Every table in a database has one or more columns used to uniquely identify each record in it. You can imagine that in my vendor table, there is a field that holds a vendor code that uniquely identifies each vendor that I do business with. This column is called a primary key. When two tables have a relationship with one another, it is represented by the primary key in one table being referenced in the second table. My vendor and invoice history header tables have a relationship because each invoice is issued by a vendor, and this is recognized by the vendor code of the vendor that issued an invoice being registered against the invoice in the Invoice History Header table. A column in a table that references a primary key from another table is called a foreign key. Likewise, my Invoice History Header table has a relationship with my Invoice History Detail table because each detail line belongs to an invoice, and similarly, this is identified by the primary key of the Invoice History Header table being referenced as the foreign key in the Invoice History Detail table. Armed with this knowledge, I can now create the relationships for my container. This is done by dragging the primary key from one table onto the foreign key in the other table. You can see in my vendor and invoice history header tables, the primary key and foreign key have the same name of vendor number. And between my invoice history header and invoice history detail tables, they have the same name of invoice number. This may, however, not always be the case, and you may need to take a closer look at the data in each table to identify the primary and foreign keys. I'm going to go ahead and create the relationships. Once done, a line is drawn between the two keys of each table with an icon appearing on either side of them. This indicates the type of relationship between the tables. By right-clicking on an icon, you can see the fields that the join is on, you can remove the join, and you can set the join type. And by hovering over the last option, you have the items inner, outer, and full outer. This is a moment for a bit more theory. With databases, there are typically 4 types of joins that you can have between tables. These are inner join, left join, right join, and full outer join. To make them easier to understand, imagine that I have started liaising with a new vendor, and I've captured them in my vendors table, but I've not made any purchases from them. Let's also assume that my business solution allows me to capture vendor purchases without initially needing to enter a vendor for them. An inner join will return the records from the first table and those from the second table where there is a match between the primary key and foreign key. So in this case, my new vendor and invoices which don't have a vendor number will not be included in the resulting join. A left join will return all records from the first table, but only those from the second table where there is a match between the primary key and foreign key. Now, my new vendor will be included in the resulting join, but will not have any invoices listed against them. And the invoices which don't have a vendor number will be excluded. A right join, as you may guess, is the opposite of a left join, and it will return all records from the second table, but only those from the first table where there is a match between the primary key and foreign key. This time, my new vendor will not be included in the join, but the invoices without vendor numbers will be. These invoices will not have any vendors listed against them. So that you're aware, a right join can be implemented as a left join, but with the order of the tables reversed, and vice versa. And lastly, a full outer join will return all records from both the first and second tables. In this case, my new vendor will be included in the join without any invoices listed against them. And all the invoices which don't have vendor numbers will be included without any vendors listed against them. Another way of thinking of a full outer join is that it is essentially a combination of a left join and a right join. Between my tables, you can see that an inner join is selected by default. To change this to a left join, for example, right-click on the relationship icon of the table on the left-hand side of the relationship and change the join type to outer. You'll see the icons change accordingly. If you want to then change the join to a right join, you could click on either of the icons and select Reverse Polarity. If you want to create a full outer join, then you can click on either of the icons and change the type to full outer. The join type you choose to use depends on the information you're focusing on from each table. For example, if I'm only interested in the purchases I've made that have a vendor associated with them, then an inner join would work fine. If I was interested in seeing a list of all my vendors together with the purchases I've made from them, then a left join on the vendors table would do the trick. If I was interested in including all the information from both tables, then a full outer join would be the one to use. Since I'm only interested in the purchases I've made, I know that each invoice will always have at least one purchase line, and that a purchase line cannot exist without an invoice. An inner join would work just fine for me in both cases. It's important to pay attention to the join type between tables because sometimes you may expect to see records in your dataset which aren't there, and this could boil down to the join type. A full outer join can be a fail-safe for this because it includes all the records from both tables, but this may also result in a lot of unneeded rows being returned and could hamper performance. My tables are now joined the way I want, but before continuing, there's one other useful thing to point out. When using the Graphical Join Tool, Sage Intelligence builds up a SQL query in the background based on the actions you make in the tool. You can see the query if you click on the Show SQL checkbox at the bottom of the window, and you can use it to help guide you as you work. After clicking Apply, the tool will close and the container properties will be shown again. Now, under the Join SQL field, you can see the resulting SQL code for the container is added. This is the query that will be executed against my database to return the information for the dataset, and it's the heart of the container. In the next lesson, we'll look at adding this type of code ourselves. Before closing, there's one last thing to show. In the previous series, I mentioned that a container can be thought of as one large table consisting of a number of individual tables. This implies that a container consists of all the fields from the individual tables that make it up. The next step in building a data set is then deciding which of the fields you want included in it. These are your expressions. To add them, select the container and then on the Home tab, click Add Expressions. I also mentioned that there are different types of expressions you can add. The first one is data fields and refers to all the fields in the container. I'm going to leave it selected and click OK. You're then given a list of the tables that make up the container and can choose to add fields from specific ones. I'm going to select all of them and click OK. Then all the fields from the tables I selected are shown, and I can go ahead and pick the specific ones I want included in my data set. I'm not going to worry about being choosy here, and I'm going to select everything again and click OK. This would ensure that all the fields are available for me to choose from when I create my report in the Report Manager. You'll then see the selected fields added to the data set. One thing you might want to do at this point is sample the data, but take note that the sample will include all the fields that are part of the definition of the container and not just those expressions you've chosen to add. Although there are other things I could do with my container now, it's basically complete. I could go to my Report Manager now and add a new report that makes use of it, but I'll pick this up in the next lesson. In this lesson, I showed you the basics of creating your own data set in the connector, starting with just adding individual tables and then combining different tables to form a more useful container. I've also shared the necessary database theory to give you an understanding of what is actually taking place. In the next lesson, I'll focus on creating my second database for my accounts receivable, working with the SQL code itself and some of the other container types. I hope you'll join me where we'll take the capabilities of the connector to the next level.